If you've been writing JavaScript for more than a year, I can almost guarantee you've written at least one of the patterns I'm about to show you. Today, in this video, I'll go through top 5 JavaScript anti-patterns and tell you why they are dangerous. Let's go. So on number one, we have using var keyword inside loops. So you write var keyword inside for loop, you expect it to print 0, 1, 2, 3, 4, but this is not what it prints. Let's check what it actually prints. So I will open a terminal, I'll write node index.js, and you see it is printing 55555. Now, why this happens? It is because var is a function scoped keyword and not block scoped, which means that by the time set timeout fires, the loop has already finished. So here, after 1 second, since it console logs the I, by the time it actually executes, the value of I becomes 5. And this is the reason why it prints 5 instead of 0, 1, 2, 3, 4. So how to fix this? Simply, you can just type let here and let me hit save and let's rerun this. And now you see it is printing 0, 1, 2, 3, 4. So here, this is the correct version. So the second anti-pattern is using double equals instead of triple equals. Now in JavaScript, double equals uses type coercion, which means JavaScript quietly converts value to match the type before comparing them. An empty string is falsy, so it equals false. 0 is a falsy, so it again becomes false. And in the same way, null and undefined both are falsy, so they become equal. Let me run the program to show you. Now you see that each of these statement returns true, but this actually causes a lot of debugging issue. You don't want that your 0 should always equals false, right? So how to fix this? You have to put triple equals instead. And let me rerun the program. And now you see that it is not only checking the value, but also checking the type. And since the types are not equal, it is returning false. So on number 3, we have mutating function arguments. Now this is a code where we are defining an object in original user, which has a name key and a role key. Name has my name, role has viewer. Now what we are doing is we are calling a function add role. We are passing the object and we are storing the result in updated user, right? What we are doing in add role is we are changing the role to admin and returning the user object. Now what happens is very interesting. If I print the original user role, it prints admin. Let me show you. Now you see it is printing admin, but the original user role was viewer. This causes a lot of issues because in JavaScript, objects are always passed by reference. So when you mutate a function argument, even without it has no meaning, you're changing the original object. This creates a lot of bugs that are incredibly hard to trace because the mutation happens far away from where the original object is used. Now, how to fix this? Well, there is a way, and you can use spread operator. So how to use a spread operator? You just enclose the user object, use 3 dots, and say role should be admin, and you remove this line. Now let me run the program again, and now you see that only the updated user role got changed. If I change this to updated user, sorry, and I run the program, it prints admin, but if I print the original, it prints viewer. Now this is the correct behavior because I don't want my original user to change its role. So the fourth anti-pattern is using delete on array items. You have this code, and now let me run this code. You see that it is printing 1, 2, but here there is an empty item, and the array length is even after removing the third element, it is still 5. Why this happens? Originally, delete is designed for object properties and not arrays. But since arrays are objects in JavaScript, it technically works. But what happens is on index 2, it creates a hole. This is called as a sparse array. Now, why this is dangerous? Because say you are looping in the array 3 instead of 3, it will consider this as undefined and it will cause a lot of issues while debugging. So what you need to do to fix this, say I want to remove the third element, I will just use a method which is known as splice, and I will put the start index here and how many elements I want to delete. So I just want to delete one element which is at the third index, and let me save. Let me rerun the program. And now you see that it has successfully removed the third element and the length is also correct. So the fifth anti-pattern is not handling promise rejection. What I'm doing in this program is I have this function which calls a dummy API and I'm returning the JSON response and console logging it. Let me run the program and you see that the status is okay, the method is get and it is working fine. But what if I intentionally make the API fail? Let's run the program. You see that the program crashed. Now this happens because we are not handling the promise rejection. And this can cause a lot of problem when you have a whole line of code and you have not handled the exception. So what you need to do here is here just you want to add a catch block and inside this I will just return a string saying error. Now let's clear this and let's rerun the program again. Now you see that our program does not crashes, but just returns a string which says error. So this is how you solve the problem of promise rejections. So I hope this video made sense for you. If it did, please like the video and subscribe my channel for more such videos. Thank you.